Good morning. We'll get started with the presentation in just a minute. All right, let's get started then. All right, this is the AI-assisted software development, Greenfield development code presents presentation. My name is John Miller. I work for Code Staffing. I'm a software developer and architect. I've played many different roles over the course of my career. Currently working on lead management projects and logistics projects. And I'm a contributor to the Practitioner's View blog, which you can see the URL down at the bottom. And I'll be publishing updates to this presentation and other presentations as well in the blog. Just a bit about Code. Code's been around for 30 years. It's got 4 different main focuses. One is consulting, one is staffing. There's the Code magazine, and as well as Code training. And we're always looking to help out other organizations with their development tasks. So let's talk about what we're going to cover today. Today, this is a new development focus presentation. It's really about how do you go about creating greenfield applications, and I'm going to take a fairly interesting approach to this. So we're going to start off talking about how to define the project requirements going into using AI to assist us in developing an application. Then we'll get into some instruction files, some agent related information. Then we'll talk about implementation prompts and then implementation verification. And that should give us a pretty good look at, from there we'll be able to look at the code that was created and talk about what some of the features of that are. So one of the things I do like to emphasize is I think that this code is pretty much on the money. This is from Ginny Rometty, who was the head of IBM for a while. It basically says AI is not going to replace us, but people that use AI will replace those who don't. So an idea here is that it's a great idea to be picking up on your AI skills and using AI to help you develop your code. It will definitely put you in a position to where you understand the technology better, and you can use the technology effectively and efficiently to be able to produce new applications. So let's just talk about requirements and what requirements are. This is a huge topic. I'm not going to get into the details of this, and I'm going to focus on a very narrow set of project requirements for this particular presentation. This is an image I found at Big Picture that talks about what project requirements are and what some of the things are. Now, also, if you go into Wikipedia and you look up software requirements, you'll see a whole list of different kinds of requirements that you could specify. But we're going to focus here on some business rules, some workflows, what the tech stack is, and what the architecture is, and try to spell that out as a part of the definition of the application that we're going to be creating. So let's just talk about this and take a look at the application. Basically what I want to do is going to start off creating some project requirement instructions. These basically we'll create them both manually and with the help of Copilot. The tasks we want to do is to create a Copilot instructions.md file or MD files That includes business rules, workflows, purpose, tech stack architecture, and then use Copilot to generate instruction files from the code-based content. We'll also review for errors and omissions and ask Copilot for updates based on evolving tech. So let's just talk about this. This is probably the core new feature or thing that I bring into this presentation. So this diagram on the left is called an object role, a modeling diagram. It's you can go to orm.net to learn more information about these diagrams. But there's a couple of interesting things about this particular diagramming style. These diagrams are conceptual, meaning they're not tied to any specific implementation. So you can project these diagrams onto database structures, class diagrams, and we'll talk a little later about how to project them against a user interface. So they're also both visual and textual. So if you look on the left, the diagrams here are verbalized in the business rules on the right. And I know this is a bit of a eye chart, and I'll get into these business rules in a little bit. But I just wanted to kind of emphasize the idea that we can create a conceptual idea of a conceptual diagram or a conceptual model of what the application is supposed to have in terms of constraints and for facts that it wants to record, and then verbalize that in such a way that we can actually use that with Copilot in order to help us implement an application. So just a couple of interesting facts I think I could point out about this diagram before we get into a little bit more detail. Is right here we have the idea that a teacher here is audited by or can be audited or audits another teacher. So this is what's called a cyclical relationship. Here is a notation that indicates it's irreflexive, which means that basically that if a teacher audits another teacher, they're they're not audited by that same teacher. Here's another fact that a teacher is both a teacher and a professor. Here, this is a multiple inheritance in the diagram. It would not be implemented as multiple inheritance in many programming languages, but it allows us conceptually to say that that a teaching professor is both a teacher and a professor, and that they serve on a committee. And then we have another fact is that an academic who is tenured, which is this fact here. This is called a unary fact. It's just either true or false. And we have them being an academic being contracted on a date. This is an exclusion constraint, meaning saying that if you're tenured, you don't need to record that there is a contracted till date. So that would meaning that we don't care about the date that they're contracted to if they're tenured because they have a full tenured position. Okay, great. Moving on then. So let's talk about instruction files just briefly. Instructions are a guide for Copilot's behavior and context awareness. This is going to be a key part of this presentation because we're going to use instruction files extensively here to help Copilot understand what we're trying to accomplish. And there are two different locations that you can keep you can store these instruction files. There are project level instructions which go within the project structure within your repository in a .github folder, and they apply only to that project that they're contained in. And then there are user levels which go into your user folder, and then they basically apply to all the projects that you might be working on that particular machine. There is a need for what I would call shared instructions, which means these are instructions that apply to multiple projects, but are not user level. We want to share them between multiple developers. And I've published a blog post on one way to accomplish that. And so if you're interested in sharing instruction files among a team, you might want to take a look at that. All right, so let's talk about generating instruction files, and both creating them manually and with Copilot. By default, or the the default instruction file is a Copilot instructions.md file, but they can be any file name as long as they end up with a .md instruction. These are all markdown files, and they're in the GitHub folder structure. So we'll also use Copilot to generate contextual instructions and review and refine some with AI suggestions. So let me back up a second. Let me switch over to the VS Code. All right, so we're looking at VS Code here. The one I wanted to show you is the first instruction file that I used in order to start this whole process on. Is that is the business rules, and this is the whole premise. The whole premise of this particular exercise is kind of like an experiment that I started, and I wanted to see how far I could get with it. Is to start off with these a conceptual model, and see how far I could go towards producing a working application from just the instructions related to that conceptual model. So this consists of basically some business rules for this academic management system. It has some key entities here listed that and what they do. It has some examples of facts that we would like to record in this particular application. So here's an academic with employee number 715. It has an employee name of Adams A, for instance. There's some reference schemes, which just means that if we have an academic, we refer to it by the employee number. If we have a room, we refer it by the room number, etc. And then we have some specific business rules, and these are the rules that that were on that one screen. A profile, there's a profile as an academic who has a rank of P. So this is indicating a business rule or a fact that was diagrammed in that model and verbalized here. A professor who has a department must work for that department, etc. And I'm not going to go through all of these rules. You can revisit them on your own time, but it is a fairly comprehensive set of rules describing a particular constrained universe of discourse or a domain that we would like to implement. And then there are a couple of derived rules, and derived rules are not actually stored, but things that we can calculate from the other facts in the model. For example, in a deployment that employs an academic of a rank in quality, if employs an academic of rank in a particular quantity, if and only if the count of each academic who has a rank and works for that department. And then here's an extension provides access level to it as an extension is used by an academic who has a rank that ensures that access level. And this isn't trying to say that there's a derivation here that says that we can derive what the access level is based upon the rank that's associated with that particular academic. All right, so the idea was then that we would start with this particular set of business rules as our main input into the application generation process. And the next thing that I did in order to produce something to go from there is to use a prompt that I'm calling here the generate instructions prompt. And the purpose of this prompt here is to generate instruction files for a CQRS, which is a command query request response application architecture in a people management system. So we're saying, okay, we want to generate instruction files here. So we're going to ask Copilot then to create necessary instruction files for this kind of an architecture of an application. It's based upon the model is based on ORM white paper, which provides a structured approach to object role modeling. All right, and then the generated files will include the instruction files for the CQRS application, instruction files for provisioning resources in Azure, instruction files for configuration and secrets management, additional instruction files needed before creating the application itself, and then prompts, and this is important here, prompts for creating, provisioning, deploying, configuring, and testing the application, including instructions for testing the implementation after each prompt. So the idea here, what I'm asking Copilot to do, is to not only create instruction files for defining how this application should be built, but also the prompts for actually building the application in the order that the application would need to be implemented, and then instructions for actually going back and verifying that prompt, when it was implemented correctly. So the context includes a diagram of the object role model for the people management system, which then can be used to inform the design of the application. So I executed this prompt, and that prompt created a bunch of things. First off, it created a bunch of instruction files that define how the application should be built. So just to kind of reiterate here, I'm starting with just one file, which is just these business rules, and then I'm asking it to create instruction files for creating the rest of the application. All right. Now these files are they're the ones that Copilot suggested. There's nothing stopping you from enhancing these in any way that you think is appropriate. But my idea was that let me just give Copilot the core set of instructions for the requirements and let it see how far it can get on its own from here. So it has Azure, for example, instructions for Azure overall. It said provision and configure an Azure resources for a production-ready CQRS academic management system, what the core infrastructure should be, a resource group, a key vault, a service plan, an app service, and application insights, what it should be doing for data storage. So here we're talking about Azure SQL, a SQL database. And remember, this was generated by Copilot. This was not something that I modified after it created. I just wanted to see what it was producing, and it's doing, I think, a reasonable job here of describing what needs to be done from as far as a infrastructure perspective. It wants an Azure Service Bus for handling messaging within the application. It talks about how the security should be built, how it should be monitored, and how it should be deployed, what the development environment should look like, staging environment, production environment, Azure's bicep template instructions, Key Vault configuration instructions, etc. So this is fairly comprehensive instructions in terms of just creating the Azure infrastructure. Again, I'm not going to read you all of these instructions. I just wanted to point out the comprehensiveness of the instructions that were generated by Copilot in order for us to start building this application. Here's an instruction file for configuration management, and this is, again, the same idea. We're just describing not only how we want to do the configuration, but here some examples for base configurations, as well as development configurations, production configurations, differences, etc. Key Vault secrets. Moving on to the CQRS architecture. This is basically defining what it should be concerned about when building the CQRS architecture. It has a command side, which is the right version, what the commands should be, the command handlers, the domain models, event storage, or our right database. And again, this doesn't really implement our specific implementation. It's describing more in general what a CQRS application should be. When we get into the prompts, it will actually be more prescriptive about what it wants to create. Then there's the query side, which is the read side. The queries, the query handlers, the models, and the database projections, what the technology stack is going to look like, what the folder structure should look like, key implementation guidelines with domain events, build the business rule enforcement. Notice it's referring back to that business rules MD file for the domain entities, how to handle errors, any performance considerations, security, testing strategy, and compliance requirements. Here's instructions for setting up the development environment, all the way from cloning the repository, dependencies, database, secrets, the solution structure, the project files, instructions for creating the individual project files, documentation and maintenance, guidelines for that. I'll skip new instructions. I'll talk about that later. Performance and scalability, response time, throughput, security, authentication and authorization, data protection, and access control matrix, and what different users in the system, what their roles are and what they can do. And then finally here we wrap up with a testing strategy instructions, and that describe, we should be seeing 70% of our tests be unit test, 20% with integration test, and then 10% with end-to-end testing. A test project structure, what a test base class might look like, integration test, what it might look like, entity testing, etc. All right, so that's the instructions that we're going to ask Copilot to use it when it goes by go ahead and doing any implementation. So the benefit of having these instruction files here in the project is that they will be applied with every prompt that we give it, which basically allows us to make very simple prompts, but include a lot of context from these instruction files in order for it to understand how we want to go about implementing those or executing those prompts. And then, of course, as I mentioned, I also asked for it to generate prompts, and it created a single prompt file, just to be clear. And then I created a separate prompt file that took that the one prompt file that it created with all the prompts in it and broke it up into individual prompts here, so that we have individual files that we can execute one at a time. So the first one here is a very simple one. It basically it consists of it's telling you what agent to use. It's specifying what are the tools that it can take advantage of in order for it to actually accomplish that task. And also remember that this is not something I created. Yeah, there's a question that is the repo be shared? Yes, definitely the repo will be shared, and it'll be I think a key resource for you to understand what I'm trying to accomplish here. And I'll go over what's in the repo a little bit later. All right, so here's the project structure. As I said, the tools that are going to be used, it goes ahead and says, in this particular task, we're going to create a complete set of QR solution structure for the academic management system. It's going to do a project structure creation. It wants to create the solution files and all the project files is specified, set up a proper project references between the layers, add all the required NuGet packages, create the basic folder structure, implement the base classes and interfaces for the CQRS pattern. And then this is the section I asked. It said, okay, after you finished executing this prompt, these are the things that we need to go through and verify that, that the project compiled successfully, that it can confirm the project references are correct. You can check that all the NuGet packages are properly restored and validate the solution structure that matches those specifications. And so what I did was basically then to start the project, I go into a new folder and create a new GitHub repo. And then I just start going into the chat window. If I were to here, go to open up a chat. And let me just make this a little bigger. All I would do is then use the hashtag. And here I see it says I have that 1.1 file open. And by doing this, I can just basically execute that prompt, and it will then basically go through the prompt and perform all of the steps necessary to implement it. It will do the verification. And then what I typically did was to go back afterwards and execute these prompts individually, or these particular portions of the testing instructions, just so that I was clear in my mind that it had successfully completed those particular tasks. And what I ended up doing was, after each of these prompts, I would go back and and go back to the previous steps and execute those testing instructions just to make sure that nothing had regressed in the implementation going forward. And that was I did find a couple of places where it needed to go back and fix a couple of things. Copilot had to fix a couple of things that were introduced earlier or introduced in subsequent steps, and that broke things earlier. So let's take a look at these different prompt files that I created. And here I just wanted to point out that in the repo also is the chat dialogue that I captured at the end of the process. It would give you a sense of where I actually interrupted this or added context to the process, and what the responses were directly from Copilot in terms of making the changes that it made. Another interesting thing about the repo that you get is that if you go into the change log, you can see all the way back to the very first commit what was actually involved in that particular project's prompt, the result of that prompt in terms of a set of files that were created and executed. All right, so let's move on to the second one. This is the domain model implementation. And so here we want to implement the complete domain model for the academic management system. We want to create all the entity classes that were defined, and notice that it is based on that business rules document. It just picked up that these are the kinds of classes that it's going to need. All the value objects. Here we had like the reference modes that we were talking about earlier. Term up as value objects. Some domain events for state changes, business rule validation at the domain layer, so that those constraints that we talked about earlier in the model all get implemented properly in the domain layer. Create the aggregate routes and ensure consistent boundaries, and handle the domain exceptions and error handling. Focus on these key entities and their relationships: academic, department, room, extension, share, and degree. And then the testing instructions were to go ahead and run domain tests, which would be the test automation that will be created to verify that these requirements are being met, that verify that all the business rules are enforced, test the entity creation with the valid and invalid data, validate value objects to constraints, and then confirm that the domain events are being raised correctly. So you're seeing that we're layering on top of the previous steps where we've graded the basic project structure, and now we're going to start to flesh out the domain model as like and finally, moving on here to the application layer. So here we're doing the application layer for the key RS commands, queries, and handlers. Here are the requirements that it created. Here are the key commands to implement, the key queries that it wants to see, and then the testing instructions are run the application unit tests, verify the command handlers, enforce the business rules. Again, we're consistently, I think, being able here to have previously defined the business rules up front. It is carrying through the implementation to make sure that we're enforcing the business rules all the way. Test the query handlers, validate the input validation, confirm error handling produces the appropriate results. Step 2.1 is these are the infrastructure layer. And so basically, it's going to create the infrastructure. This starting off with creating entity framework, a DB context, implement a repository pattern, create an event store, a service bus, model projections for Cosmos DB, database migrations, providers and dependency injection, and health checks for all the external dependencies. Here's the infrastructure components, the database schema. The testing instructions are to run the infrastructure test, verify the database migrations work, test the repository implementations with the in-memory database, confirm the event store persistence, validate the service bus, and check the health checks of the appropriate statuses. Then moving on to the API layer implementation, this is going to be controllers, middleware, configuration things. So we're going to create controllers, implement the proper HTTP status, add comprehensive input validation, implement Open API and Swagger, authentication and authorization, logging and monitoring, CQRS. Look at that. Spelling error. Configuration for front-end integration and health check endpoints. So they can implement controllers, some API features, and then test instructions are to run the API test, start the API up, test the Swagger, verify the endpoints, test the error handling, confirm the authentication, and check the health endpoints. So moving on to Bicep. So this is going to be implement the infrastructure. So create main Bicep files. In the interest of time, I think I'm just going to just briefly cover what the testing instructions are, and we can kind of move through. We still have a number of instructions, prompts to go through. Validate the Bicep templates. Deploy to the development environment, verify all the resources are created, test the connectivity, confirm manage identity, has the proper permissions, validate the key vault access and secret storage. And here's some configuration and secrets management. This will be about setting up the key vaults and properly storing the secrets in the key vaults. So we deploy configuration to Azure, test the application startup with the configuration, verify the key vault access, confirm all secrets are properly retrieved, test the configuration, check the health check endpoints. In here we have a prompt for creating the CI/CD pipeline. Trigger the pipeline, verify all the build stages, confirm the test runs and pass, test the deployment to staging, validate the end-to-end test pass, test the rollback procedures, and monitor the deployment metrics and logs. Here we do add monitoring and observability onto the application. Here we have test instructions for deploying and monitoring, generating test traffic, verifying the custom metrics, the testing the alert rules, confirming the logs, validating distributed tracing, testing incident response. And then we get into the last a couple of steps or prompts, which are the comprehensive testing. And here we're going to be basically going through and running all the tests, executing a load test, verifying test coverage meets our requirements that were greater than 80%, test that the business rules are enforced, confirm the error handling, validate concurrent operations, generating test reports, and then finally is the end-to-end validation. Perform the end-to-end validation and complete the academic management system before production go live. And basically, here we have a series of go live activities that we want to execute as a part of the go live effort. Execute complete validation tests, perform load testing, test all critical business scenarios, validate monitoring, confirm backup and recovery, test incident response, verify the system meets those requirements, and documenting issues and resolutions. So that's a lot of words. I know it went by pretty quick. I would encourage you to go back and look at the repo and take a look at these. All these prompts. Yeah, I've got a question. Yes, all of these prompts were generated by AI. The only thing that we started the whole process with, just to recap, is we started with a business rules instruction file that contained the business rules that we expected the application to be able to enforce. And then it generated basically a series of instruction files that would guide the implementation and a series of prompts that would actually perform the implementation. All right, so that's that recap. I guess the big takeaway I would have for this, let me switch back to the slides, is that this is a fairly, starting with a fairly simple beginning that did not take an enormous amount of time to produce, is produce a fairly comprehensive set of instruction files and prompts in order to do an implementation. There's quite a bit of detail there, and at first glance, it seems that if Copilot can produce something that actually meets all these testing requirements, we have stand a pretty good chance of actually producing something that's workable and, if not production ready, very close to production ready. So let's move on to the next slide. So we talked about the implementation prompts and the verification logic that what it produced. So it basically, talked about how they created the prompts, what the verification logic in that prompts, and how do we ensure safe execution of those prompts. And we reviewed the business rules instructions, then the prompt to generate the instruction files, and the actual generated instruction files. And then executing the prompts, as we also talked about this, and we use those prompts to guide those agent actions and verify those outcomes. So we reviewed those the prompts that were created. I executed those through this chat mode. I show you how I did that. I showed you what the responses look like, and then I talked about how I verified those results. All right. Well, let's go before we go into this. And let me. Let me talk just a little bit more about the code that was created since we've gone and produced all of these prompts. Let me go back to the code base. And here, this is all of the prep work, let's take a look at what it actually built. So, a whole bunch of stuff here, but everything, any consequences are going to be under here, under that. So we have the API implementation, the health checks, etc. One thing I can show is if we go into our terminal window. Let's change into our people folder, and if I just run .NET test, this will show you the state of the code base as it currently exists in the repo today. And so you can get a sense that this application has been implemented and it does actually do some things as evidenced by the tests. And since this is an API, we can actually execute the API. And you see here it's going through all the tests now and running the tests. A question about how do I execute those files? Basically, I ran them one at a time because I didn't want it to go. I wanted to have a chance to verify the steps and capture the responses as I went along. So I went into the chat mode here, and I just referenced that prompt file from the prompt folder here. You can see the prompts. So here's prompt 1.1. I just referenced that file. I can show you how I did that again. You just get rid of that. Here's a pound sign. If the file is open, you can see it. Otherwise, if you could just type 1.1, notice that it finds that file and you can reference it there. Another question about whether I would do this as an iterative process, and my answer to that was definitely yes. The reason I would say that is that I went through this as a very hands-on kind of a vibe coding mode where I did not really provide additional context to Copilot when I was creating the app. What I what I would do is if it was headed down the wrong direction, or if I could do something that would clarify what it was trying to accomplish, I would provide some feedback to that, and I did a lot of approving of steps as it went along. Um, but if I was doing this with a real application, I would definitely go step by step and do a lot more verification of of the the output. For example, just going through and verifying with the team that all of the instruction files were complete and were accurate would be a great first step, because it's essentially kind of a garbage in, garbage out scenario, and we're doing a lot of upfront providing of context that is going to have an impact on the code that gets generated. So we'd want to try to make sure that that's as accurate as we can make it. And of course, you're not going to get everything right up front. In fact, I'll talk about what I missed when I started this project and what I would take into the next round of doing something like this in a bit. But also, after you execute a single prompt, if you go to that first prompt, don't want to take, even, I don't want to, if I go back and to look at this prompt here, you can see here these testing instructions. I'll go back and ask it to do these steps and verify these things, but I'd also want a chance to make sure that I get a chance to look at this and make any adjustments to the implementation before proceeding on to the next step. Possibly, if I see anything that's any significance, I might even go back and add that information or context back into the instruction files and start over again and have it recreate those steps. The other thing I would highly encourage is to use a branch for doing the development on it, and doing and committing to that branch on a regular basis. You want to provide yourself with a way to go back, and if for some reason the AI took you down a path you really didn't want to go. Okay, so we were just kind of taking a browse through the code base. You notice here that it ran 309 tests with 4 warnings on the build, which is pretty good result. Figure that it's running a whole bunch of unit tests and integration tests in order to make this happen. So this is a good sign. Just to go through, I don't want to get into too detail of the implementation, simply because there's just a lot here to go over, and we're quickly running out of. We're going to be running out of some time, but it did actually produce working code, and it did actually produce code that compiles, and it has outside of a couple of warnings, which I haven't had a chance to have it go back and try to fix. I think it's a pretty clean build. So here is some of the health check implementations for Azure. We talked about controllers, the base controller, the academic controllers, filters. Here's some health checks, some middleware. Then we have some application behaviors, the actual domain model. Cool. Now, the other thing I wanted to point out, during the course of building this out, it created a fairly comprehensive set of documentation on various things that it did. For example, what the testing strategy looks like, A question about performance metrics and architectures. Well, I specified in my initial prompt for generating the instruction files, which is the generate instructions prompt files, that I wanted a CQRS architecture. And so here I'm giving it explicit instruction, not very detailed, but so so that's for the architecture. Would I recommend this approach using other tools? It just depends on what are the capabilities of the other tools. I'm not familiar with Cursor, so I can't tell you whether it supports something like an instruction file or a prompt file. But I would speculate that there would be something similar to this in other environments. And I would tell you that the AI, the instruction files for the AI are very important for controlling the output that you get. Otherwise, if you don't have instructions that the application that the Copilot should use, in order, you may not see things that you really like in the output. This really allows you to focus the output on what you expect it to produce, and I would highly encourage using an approach like this with whichever tool that you're using. All right, so I was talking about the documentation, lots of testing guides here. Here's an application layer summary, describes the different application layers and what they do. Azure credentials. Notice there's a few fixes here, plans where we ran into some issues, and you can see those in the responses that I captured, where it needed to kind of come up with a plan to fix a problem that we encountered during the course of the implementation. And, sometimes it definitely would get stuck on an issue, and we'd have to iterate over a problem for several minutes in order for us to come up with a solution. Infrastructure summary. So good. Also a good place to review this and take in terms of the documentation itself. So let me switch back to the slides. And I want to talk a bit about what I didn't get to implement. And that is I had intended to, but at this point ran out of bandwidth for, is to generate a user interface that would front end this back end CQRS application. And so my premise is that a UI could easily be derived from the same conceptual model that was used to produce the CQRS back end side of things. So the idea would be is that we would start with an object in the model and pick any object like room, for instance, and project what we think the information on a screen would look like for that particular object if you were to, say, focus on a page that was describing a specific room. And here you can see if we use like a heuristic that says anything that has a dot associated, meaning that it's a required piece of information, that we would want to see that on that room screen. So we would project to see that we would want to see the academic that the employee number of the academic that the employee number, the academic, and we'd also want to project that into potentially the employee name of the academic that occupies that room. So a couple of questions. How long did it take to produce this application? This was over the course of probably a little over a month worth of work, but it wasn't full-time work. It was basic work in my spare time or off hours to actually go. And the work primarily consisted of going through and executing those prompt files and basically supervising the implementation of those prompt files. In terms of the tool that created this diagram, there's an add-in for Visual Studio called Norma, Norma. But I didn't use this tool. I took this diagram from a site called orm.net. Um, it's a site that's dedicated to discussions related to this particular modeling style. And you can, if you can find this academic discussion there, as well as a very complete description of how the model was produced, which would give you, I think, would give you a great understanding of, you know, how this, how you take a, how you would take a problem domain of your own, that's of your own particular solution or problem, and construct a model based on that solution. I got a question about the cost. Are you talking about the cost that the direct cost, indirect cost? I'm not sure what cost you're referring to. All right, so so we talked about the room number. Also, we would want to see in that room number what the room number would be, what the building number would be, and then by extension, what the building name would be. We want to see those, I think, all on a room form. And if we were looking at a professor, let's say down here, we would want to see things like, what chair that they hold, what department name that they had, what department that they work for, what is their employee name, uh, are they tenured, and if they're well, let's see. If we could probably skip on these since these are not required. We'd want to see what a list of the degrees. Now, notice this would be a container, a list of things of the degrees and the universities that they were obtained from. Obviously, the room that they occupy, their extension, their rank. Oops, I got lost. Can't click on things. So the idea here that I have is I can easily envision coming up with an instruction file that would allow us to you come up with an instruction file that would able to interpret not necessarily the diagram, but the verbalization of the diagram, and then produce a user interface or a set of pages or a description of a user interface that could be implemented, and that allowed you um, to use that as the front end to this back end. And what I think is kind of cool about it from an implementation perspective is that that if you're an academic and that academic is occupying a room, that room information that you see on the academic page should have a link to the room, which would then take a page that would give them the information about that, more detailed information potentially about that particular room. And the same thing is true for some of these other entities as well, like departments is a key entity here that has a lot of different information that we probably wouldn't show on the academic screen, but we would show on the department screen. Yeah, there was a question about being able to produce a diagram from a hand drawing. That I'm not aware of anything that can do that, but there may be something out there that's capable of that. I am looking at looking at a mermaid spec that would allow you to essentially use mermaid to build these kinds of diagrams as well. The problem with just having a mermaid rendering of a diagram like this is that it doesn't understand the basic constraints and of the diagram itself that are used as a part of the verbalization. Okay, so I talked about that. So follow the blog. Definitely, I'll continue to work along this line. So that you might expect to see this UI work show up later on. All right, so lessons learned. So review the code that's created, especially the test automation code. The test automation code, I think, is a key code here, and you want to make sure that you understand that code that was created because it's what you're relying on to verify that the implementation that's being generated is working without actually having to go through and examine every single line of code for its correctness. The test should be able to tell you that it's correct, and you just need to verify that the tests are accurate and actually testing what you expect them to be testing. I referred to this earlier. There's a when you're using agent mode to generate out of this code, it gives you the option to keep those changes or revert them. I would keep those changes and commit them to a branch often and use the branch as your way of backing up. And what that does is it allows you to keep your code commits smaller, and which gives you the ability to roll them back a lot easier. You definitely want to provide yourself with a safety net so that you don't go down a blind alley or something and find yourself in a position where you got to roll back a whole bunch of code. Be a bit more prescriptive about the tech stack. I mean, I was just talking about CQRS, but I could have been more prescriptive about the Azure implementation, about using a container versus an app service versus other kinds of technology decisions. Be clear about the definition of done. This is, I think, important to kind of give Copilot a sense of what your workflow looks like and what what you consider to be finished and what needs to be included in that. What test automation has to run, etc. What documentation needs to be updated. You want to make sure that all of that's taken care of as you go along, and not something that you have to retrofit at the end. And make sure you don't proceed if there are errors and even warnings. I tend to want to fix those things as they come up, keep the project as clean as I can as I go, and that it just makes it easier to add on top of the project as you add more and more complexity. Define the expected developer workflow. I kind of mentioned this. Work on a development branch, use the test automation, establish what the quality gates are. Merge to main when the app is in a deployable state. So CI/CD might be set up to be set up to only deploy from main. So you want to, in order to be able to make sure you're continually exercising your CI/CD and your deployments into your other environments are working correctly, you want to keep merging to main as often as possible. I don't like feature branches. I try to work from main as much as I can, but I'd like, as far as when I'm generating code from Copilot, I want to. I'd like a branch in order to be able to isolate those changes. Basically, so I can do more commits. Be clear about the infrastructure constraints and standards. That's like in terms of what you want that infrastructure to look like. It's a good idea, I think, to specify those kinds of things up front. And you want to also make sure you're using like GitHub features where it will verify that you have no secrets committed to source. That's something I needed to kind of keep on top of the AI to make sure that it wasn't actually doing that. All right, so just moving on quickly. So I want to talk about this new instructions.md file because that's the only other instruction file that I created by hand, and I just wanted to, and I created that not at the beginning, but as I went along. And so let me just break up that real quick and switch to VS Code. So first is new instructions. Got that. And VS Code. So you should be seeing my instruction file. Let me give you some room here. And basically, these are just a kind of set of random things that I found during the course of executing the prompts that I wanted to kind of capture and incorporate this back into the I wanted to incorporate this back into the the instruction files that I started with, maybe on a second pass through this process to see if I can improve the quality and maybe the time it took actually to produce the application. Oh, and just as a side, one interesting thing is I did have a personal instruction file that asked Copilot to estimate the duration it was going to take to estimate estimate the steps, and in one case it estimated it was going to take 3 to 4 weeks to actually implement the application, which kind of turned out to be true. All right, so there's that, and I also probably most importantly added here a bunch of workflows based upon those business rules that you would expect to see, like to promote a lecturer to senior lecturer, promote a senior lecturer to associate professor. These are common use cases that you would expect this application to be able to support. And I would think it would be a good idea to put these into the main instruction file coming right at the very beginning, so that you're not only describing the structural definition of the application in the conceptual model, but you're also providing kind of a sense of how this application is going to be used. All right, let me. So another question: what happens if you decide to add students? Would this be able to include students into the software, or have to change the whole set of rules? No, the whole goal here is to be able to manage the whole academic system. So not only should you be able to add students, you should be able to add departments, you should be able to add rooms, you should be able to add buildings. All of those entities are a part of this whole domain, and we want to be able to manipulate that whole domain, which means that the final application should be able to edit all of that information, and should be able to do it in conformance to the business rules that were defined up front. At least that's the goal. That's the idea. Start with what the business requirements are and see how far we can get in terms of producing an application that can implement those business requirements. All right, moving on to some tips and tricks. All right, so here's a VS Code setting that you would want to take a note of. What it does, it says integrated focus after run. The idea behind this is that when you're executing statements, so it doesn't create a new terminal window every time it wants to run a new command. I've had mixed results with this, but it does make it a little bit better. I have seen a problem where it will open up a new terminal window, and that will start at a different working directory, and the commands will fail because it's in the wrong directory, and Copilot has to figure out where to change the directory to in order to be able to execute things. So this kind of a feature is, I think, useful to try to minimize the amount of work that you have to do for that. It's very tedious. On your instructions here, these are like additional instructions that you want to maybe include in a personal file before making any code changes, file modifications, or system operations. Say what you want to change, where the changes will be made, why the changes are necessary, how the changes will impact the system, and then ask for permission to proceed with the changes. I think this is an important prompt in that you do sometimes, if you take a look at the plan that it's trying to implement, if you see issues with that plan, you may want to actually stop the execution, don't proceed, update the prompt or the context in order for it to understand better what you're trying to accomplish, and then proceed from there. Also, a different instruction when on automated tests, you want to report the code covered metrics, separate the instructions into groups, project specific and generic specific. And then I talked about that shared instruction blog post. If you're interested in standardizing those instruction files, which are generic across all your developers, this is one way of accomplishing that. I did see another question, so let me bring that up. Can these prompts be used to derive epics, user stories, and tasks so they're planned for in sprint backlogs? Well, I guess the question would say it would be if these things are things that you don't want the AI to implement, but you want to create a user story for or something like that that will go into a tracking system. I would say, yeah, you just have to change the prompt that you're creating. For example, if you can define something called a template that would describe what some output that looks like that you can put into your GitHub folder, .github folder, and then when you say I want to create a user story, for instance, it knows the structure of that user story, and you can then say, okay, I want to create a user story for this particular uh, use case. It will be able to derive from the current context what it knows about it in order to be able to produce a user story. And depending upon what tracking system you're using, it could actually create the user story and put it into the tracking system directly. All right, continuing with the tips and tricks. I talked about those, so let me moving on. I think one more slide of these. All right, so these are related to prompting. When encountering error, this is really kind of cool. So in one application I'm using, I've got, and in this case, once you've got a UI into the mix, you might have a whole separate project, which is or solution, which is just for the AI, the UI piece of it, and then another solution for the backend logic. So I'm working in the front end logic, and I'm encountering an error that is likely a problem with the back end. You can just ask in the chat window for the front end, you could ask it to create a prompt to investigate that issue on the back end. And so it will spit out then a whole series of information that you can then just paste into the chat window for the solution on the back end that will help it figure out what the issue is and fix it. I found that worked really well. I find that, however, that these things typically have a poor short-term memory, and these are some of the things that I've seen it produce that kind of indicated of this. So I've noticed that you've made manual edits when I have actually not made any edits to any of the code that it created, but it somehow thinks that I have, and so it complains that I've made those edits. Be wary of anything temporary, as it may not be reverted. What I mean by this is that sometimes we'll go down a path for fixing a problem where we'll disable something or comment out some code or implement it in a different way. It's a good idea to make a note of those things, and it often will produce a list of next steps or things that need still to be done. I always try to capture those and put those into a note that I can go back to and make sure that those things get taken care of at some point in the future, because it doesn't always remember to do that. Here's another prompt I thought was kind of funny I got yesterday. It says, aha, the debugging code is still there. I just thought that was, okay, that debugging code was code you wrote. So if it's still there, it's because you left it there. That was my takeaway from that. All right. The other thing I wanted to point out was quick chat. So let me switch quickly back to VS Code and just show you what I'm talking about with this. So quick chat is up here. You can basically go here and say, I want to do a quick chat. And it will just open up the ability to write a prompt right directly here in the command line in Visual Studio Code. And I find this helpful when I want to do something that's not totally related to the current prompt that I'm working on that might be somewhat complicated, and we may be working through an issue, but I want to go out and find something out. I can do a prompt here, and it doesn't affect what I'm doing in the main chat window as well. So that's something to keep in mind of. You definitely want to try to keep your contexts separate from each other. And so you want to be able to. So this is one way that you can do that. Stop and continue. So this is something that you can do when you're running a prompt in the chat window. If I was to look at that, you can stop the chat by this turns into a stop button when you actually are running a prompt. You can stop that at any time in the middle. And what I found that you can do is that while you've added whatever context that you wanted to add or any additional instructions, you can just say continue, and it will try to pick up where it left off. Here's another question. Let's switch to that real quick. Have I had many cases where ChatGPT truncated a file, leaving out hundreds of lines of needed code? And the answer to that is I have seen some issues where it will report a corrupted file. I find that highly suspicious that it thinks it's corrupted, and it will then try to rebuild that file. This is another reason for having a lot of commits and things pushed into to Git on a regular basis, so that if something like this does happen, you can go back to a previous version. But yeah, I have seen this kind of thing where corruption or some sort of where information is lost, and occasionally I have to go back and resurrect it from a previous commit. Yeah, I guess what my point is, and I think the point of this question is that you have to be defensive. I kind of try to think of treating the Copilot as an assistant who is sometimes more of a savant. It's very, very, very smart in some things and not very smart in other things. And so you kind of have to, you kind of have to stay on top of it. You have to, kind of make sure that you're doing a good job of supervising what it's trying to do. And going back to the slides, if I'm still there. No, I'm not. Let me switch back to the slides. This to watch out for rabbit holes. I've seen some cases where it'll encounter some sort of runtime error. You give it the error message. It looks at the code, tries to figure out the error, implement some code. You run that code, it doesn't work. You paste in the error message. It looks at that, spits out another version. You try that, it doesn't work. You send it that error message, and then it gives you back the implementation that it started with. So now you're basically back where you came with, and you got to take some steps to try to break that cycle. Other cases, I've just seen it kind of get diverted and go down rabbit holes that are not productive, and you just need to be able to stop and redirect it, or give it additional guidance or context, and then get it back online again. All right, so we're just about done. I want to talk now about what I call the nice to have dilemma. This is something I've done some looking at, but this basically some facts I had ChatGPT pulled together about backlogs and technical debt. And basically what it is we talked about enterprise teams having between 300 and 500 items in their backlog, with some reporting over 1,000 items, depending upon the scope and organizational size. So this is like a huge backlog. And what I mean by the nice to have dilemma is that in all the backlogs that I've seen in my experience, is that you almost never get to anything that's considered a nice to have. Everything is always, if it's a nice to have, it gets to the bottom of the list, and it just never gets done. And then if you look at technical debt and the combination of technical debt and feature debt, these are just basically growing over time. And I guess my point is that, going back to the original point about you're going to somebody that understands AI is somebody that's going to be somebody more valuable in the future, is that this is the kind of thing that I think AI can have a a real impact on reducing backlogs, because you're able to be more productive and get things, and individual developers should be able to get things done faster. I've heard reports for, getting 2 weeks worth of work done in 2 or 3 days. Those kinds of things with the assistance of AI will allow us to help whittle these backlogs down and get it to the point where we're actually being able to execute some of these nice to have things. All right, so that is my presentation. I just encourage you to visit codemag.com and take out some of there's a lot of good free resources there that you can take advantage of. And if you have any questions, you can get them answered there. In terms of this particular session, so here are two QR codes. One QR code is for a survey. Appreciate it if you take a few minutes and fill out that survey. Everybody that fills out that survey will be entered in for a raffle for a Amazon gift card. And the second one is a subscribe URL to get a free 1-year subscription to Code Magazine. All right, let's wrap this up. Just oops, one too many. All right, just to wrap this up, recap of key learnings. One is I think that in my opinion, I think my experiment was semi-successful. I didn't get to the point where what I was hoping to be able to do was to generate not both end-to-end unit tests and get those tests to run against a working staging environment, and create a user interface on top of that would actually allow us to perform some of those use cases. But I wasn't able to get to that point. But I definitely feel encouraged that I'm going to be able to get to that point in the near future. So I would encourage you to follow the blog. It's to see how the progress that I make on that. And one of the things I look into to do the next time I make a pass through this is a blog postings essentially after every prompt, and that way you could either follow along on your own or just see how things are progressing one prompt at a time. Surely an open discussion. If you had any feedback or any comments on this, I would certainly be interested in it, because it's a bit of a unique approach. And then in terms of the repo, there's the link to the repo is on the page. Review the instruction files, review the prompt files and the captured responses, and review that generated documentation, and also, of course, review the code itself. All right, I did see one question come in, and if you have other questions, feel free to post them. Another question was, surely we would derive the prompts from the epics, the features, and the user stories. Well, like I said here, what I did was I did not generate detailed use cases or user stories or epics for this, but I'm not saying that wouldn't be helpful. But I'm not sure it was necessary either. So my goal with this in this experiment was to try to have to specify as little context as possible and still end up with a working solution. So if I was to go about this on a true production greenfield application, I would provide more context up front and user stories and more descriptions of what the expectations were. I think would be beneficial and would improve the quality of the output and possibly reduce the time taken to produce it. Other questions while we're here? All right, then. I really appreciate your attention, and I wish you good luck in the future.